So this first lesson in the geometry and trigonometry units is mainly just about getting us used to thinking about three-dimensional space and three-dimensional space with regards to coordinate systems, which may be new. What's not new at all is thinking about two-dimensional space with coordinate systems. You have your x-axis and your y-axis, which refer to, horizontal axis and a vertical axis. If we throw in a third axis, that's a three-dimensional axis. And really most of what we have here is just kind of taking ideas you've learned about in 2 dimensions and taking it to third. It's not a big change. So first what I have here are the vertices of a three-dimensional image. So if you look at this diamond here, it's actually not a diamond, it's a three-dimensional image. And you're given the coordinates of 3 of the points. So A is at 2, 0, 0. So that means point A is at 2 on the X, 0 on the Y, and 0 on the Z. So it's right, and so if you imagine, quite often we imagine a z-axis is coming out from the screen or from the wall or however you're visualizing this. But this is at 0 right now. We have B, which is at 0, 0, 2. So I'll label that up here. So 0 on the X, 0 on the Y, 2 on the Z. So you can imagine it floating 2 units out from the screen. And then M, that's the midpoint of all these points. Midpoint being, as it sounds, just the point in the middle, which is at 0, 2, 0. So 0 on the X, 2 on the Y, 0 on the Z. All right, and our task is to find the coordinates of these 2 remaining points, C and D, which using the midpoint is actually quite quick. And while there are formulas you can see for midpoint, generally a midpoint is just halfway between 2 points, halfway between X coordinates, halfway between Y coordinates, halfway between Z coordinates. And so if I want to start with finding C over here, well, let me look at my X coordinates, my Y, and my Z. And if I look from A to M, my X coordinate goes from 2 down to 0. And so halfway between A and C, my X coordinate has gone down by 2. So if that's halfway, well, complete the journey, and should go down another 2. And so my X coordinate should now be at -2. Same idea for Y. I go from 0 to 2, so my Y coordinate as I go from A to M goes up from 0 to 2, so it should keep going up another 2, and should be at 4. And my Z coordinates never changed, so that means all these points, A, M, and C, are all right on the, they're not above or below the page at all, and so from 0 to 0 doesn't change, should not change again, and so there's my coordinates for C. And should work in reverse as well. Same idea for going from B to D. So we'll go from here to here. Let me look at my X coordinates, then my Y coordinates, then my Z coordinates. So as I go from B to M, my X coordinate does not change. So the same thing should happen from N to D, since these are supposedly midpoints. Otherwise, they would not be midpoints. If I look at the Y's, I go from 0 to 2, goes up by 2, should go up by another 2, so now it's at 4. Look at Z, goes from 2 down to 0, should go down another 2, so it's at -2. So there's my D coordinates, there's my C coordinates. All right, so here I want to think about a situation in 3-dimensional space. I have a drone that's controlled, it's a remote-controlled drone that's 400 meters north and 200 meters east of its operator. Now, just that alone, thinking 400 meters north, we can think of that as being, 500 meters north, we can think of that as being on the y-axis, and 200 meters east, we can think of that as being on the x-axis. But as well, it's 20 meters high, so we want to think about that as being on the z-axis. So if we wanted to, we could think of this being the coordinates 500, 200, 20. My X, Y, and Z. And I just realized I wrote those down wrong, so it should be, my apologies, it should be 200 X first, then 500, then 20. All right, that's it. After travel, and it's also traveling at a speed of 2 kilometers an hour due north at a constant speed. And so we want to find out after 30 minutes, how far is it from the operator? So first, let's get a few things set up here. Well, it's tough to make a visual that accurately in 3 dimensions. Let me start with a 2-dimensional visual. And my screen's going a little crazy on me. Take 2. So I know this drone starts 200 to the east, 500 north, so 200 x, 500 y, so I'll say like roughly here. So this I can label as just 200, 500, but it's also 20 meters high at the beginning, so we almost imagine a z-axis, again, kind of coming out three-dimensionally, so you can imagine this point also being up here, 200, 500, and 20. But it's moving due north at a constant rate of 2 kilometers per hour. Now, I got a mix of meters and kilometers here. I like to keep everything the same. Most of my measurements are in meters, so I'm going to stick with meters. So 2 kilometers an hour is 2,000 meters per hour. And we want to find how far it's traveled after 30 minutes. Well, if it travels 2,000 meters in 1 hour, half of that is 30 minutes. So it should travel 1,000 meters in 30 minutes. Which means, of these coordinates here, my y coordinate should have changed up to a higher number, up to 1,500, because it's now traveled an extra 1,000 meters north, 1,000 meters in the y-axis. So after 30 minutes, this drone is no longer at 200, 520, it's at 200, 1,520. It's still 200 meters to the east. It's now 1,500 meters north of the operator, and it's remaining at a constant height of 20 meters. So now the question is, how far are we from the operator? The idea being the operator is right at 0, 0, at the origin. And so we have a three-dimensional space, and we want to find the straight line distance, which is just the Pythagorean theorem from 0, 0, 0 to 200, 1,500, 20, but in three-dimensional space. And that's essentially what this is showing right here, the Pythagorean theorem in three-dimensional space, which is quite pleasant to work with because one of my coordinates is 0, so I can just go straight to the distance equals the square root of my x coordinates subtracted from each other. But again, one of my set of coordinates is just 0, 0, 0. And so I can just say my x coordinates are all going to be, it's going to be 200 squared plus 1,500 squared plus 20 squared. And again, what I'm using is this formula right here with one of my sets of coordinates, either x1, y1, z1, or x2, y2, z2, all being 0, 0, 0, where the operator is. Hence, I don't really have to do any subtraction here. And perform a quick calculation, and we get approximately 1,513 meters. That's the straight line distance from the operator to the drone after 30 minutes. All right, last question. It should be fairly standard. I have a right pyramid here, and it has a square base. I want to find the surface area and the volume. We do want to remember volume of a shape like this. The volume is the same as 1/3 the area of the base. So in this case, 1/3 12 squared times the height, which is 8. And you've learned these things before, most likely in middle school, actually. But a quick review. And so 12 squared is the area of the square base. 8 is the height, because again, if I visualize on here, this height here, this 8 is where the height meeting at a right angle going straight up. And so at this point, I can just calculate this, and I should get exactly 309. There's no units given here, so I'll just say cubic units. So if these were all centimeters, it'd be 300 centimeters cubed and so on. Surface area is the area of all the faces added up. So in this case, I got 1 square, which is 12 squared, plus these 4 triangles. There's 4 of them. They're all the same. And remember, the area of a triangle is base times height divided by 2. So if I look at these triangles, the base of each is that same 12. So my base is 12. The height, I don't know yet. The height of each triangle is actually this diagonal. It's a straight line, but it's running on the diagonal, on the slant, we say. That's the height, which we don't know immediately. But as perhaps you can see, we can figure out using the Pythagorean theorem, because if I look at this new right triangle that's now being created, it has a height of 8, it has a base length of 6, right, half the length. And so I can find the height by using the Pythagorean theorem. So height will equal the square root of 8 squared plus 6 squared, which leads us to exactly 10 units. And so now I can go back to what I have here. Instead of base and height, I can say the base I knew all along was 12. The height I now know is 10. And so what I've highlighted in blue here, that's the area of one of these triangle bases, which I'll just simplify now. So I get 144 plus 4 times. It comes to 60. Each of these triangles has a area of 60. Add this all up, I get 384. And these are square units, so I'll say square units. Again, if these were in meters, it would be square meters, and so on.